Hello AP Stats students and welcome back. This is still chapter 2. This is our second example from our sheet, and what we want to do is we're continuing to work with two-way tables, okay? And in fact here we kind of throw in like almost a three-way table. And the way we do this is we have, it looks like people who either died or survived from either hospital A or B, and then it looks like they started in good condition or poor condition, which is like our third variable. Okay, so it says if a patient is in good condition. Okay, good condition instantly means I don't care about this poor condition, right? So which hospital is better for survival? Okay, well, there's 600 of each, right? Each of the hospitals, that is, right? It does say which hospital, so it's like I care about the hospitals. Now, what percentage of these 600 died for hospital A or hospital B? Or a better way, right? It does say survival, so maybe I just care about the two. So when I'm looking at this, for hospital A, I'm caring about this 594 divided by the 600. So that's 594 divided by 600 versus the hospital B, which is 592 divided by 600. Remember that it's only 600 because they both added up to that. Well, clearly this 594 here is just a little bit better, right? I think it ends up being, if I divide them out, like 99% versus 98.72, okay? Which is going to matter, right? Especially if you're with one person in here and they have those 600. So here, which one would be better? Well, clearly the 99 is bigger, so that makes whichever one had 99, which was the hospital A. Okay, so that's our first question. Now, because I write all over these and things like that, I think I'll just clear this, start with a new blank slate. If a patient is in poor condition, which hospital is better for survival? Okay, so same type of thing here, but okay, now they're in poor condition, so I don't care about these over here. Now I just have to add these up over here. That's what, 1500, and then this is 200, and we care about surviving again. So I'm taking the 1443 divided by 1500 and the 192 divided by 200. Okay, well, that gives me 96. Well, here, let's not write it there, let's write it in a good spot. This number here ends up being 96% for hospital B, whereas hospital A's number is 96.2%, which means that I'm doing 96.2% versus 96%. Well, again, this one's better, which belonged to hospital A. Okay, same type of thing here. I think I'll just erase and I will restart with a blank canvas. If you combine both tables for all patients, which hospital is better? Okay, so I think that means that they're talking about initial conditions and things like that. Like, it doesn't matter if you come in good health or poor health. So I just care, really, in reality, I care about if you died or if you survived, and if you went to hospital A or if you went to hospital B. Okay, that's the things that I care about. Now, if I'm doing this, right, well, I need to add them up. So I'm thinking about people who, like, if I'm going for, say, just this number here, okay, this is died and went to A. So how many people died and went to A? Well, that is this 6 and this 57, right? So that makes my, what, 63 then? Get this out of here so I can write. That is 63, okay? And then I'm just continuing that for the rest. Who died and went to B? Well, 8 and 8, so that's 16. right, survived and went to A. You can do that one there on your own. I think that's 2037. And then I have 784 for B. Okay. Now the key is I care only about how many people went to B. Well, how many people went to B? Well, that is here for B, that was what, 600? And then 200. So that is a total of 800 that sits over here. Of course, I could have just added these two numbers up here. How many people went to A? Well, that's 2,100. Okay. Now this should set us up for success. It should help us out. It says which hospital is better, right? So you could either think about this as what percentage is lower for death or higher for survival. I think most people want to think higher for survival. So I'm taking this 2037 and I divide by this 2100. Okay, which would give me, I believe, to be 97%. Okay. If I take 784 divided by 800, that is a 98%. Okay. So looking at these two numbers, it looks like B right now is better. Okay. Well, you can check the death rate too. Okay. If we check the death rate, that is 2% here and a 3% for A. Well, B's death rate is lower than A's, so B is also better according to deaths. Of course, that shouldn't surprise us because they either die or they survive. There's not another variable to choose from there. So B is better. And if I have to rationalize it, I would say because 98% is bigger than 97%, and this is survival, and what, 2% is less than 3% for death rate. Okay, so a couple different rationales, both of which would give the same idea. Now, there is one other thing to consider here, okay? This is a completely solid answer. In general, do you think there's a reason why B maybe outperformed A? This idea here is, well, they only treated 800 patients. So they didn't have to treat nearly as many people, right? If they get one bad patient, right? A single person comes in really poor health, okay? That number then, right, just that one person would increase this to 17, right, and increase them by like 0.1%, okay, which really drives their numbers home. Now, of course, they could continue at the same rate, okay, but this idea of thinking about how big a population is, as well as, well, if you combine them, you don't necessarily know like other variables that would be in there. Here, if we just had this, if this is like where I started the question, right here, and I asked you, you'd be pretty convinced that B is better. But remember our first two questions, right? If a person's in good condition, we chose A. If a person was in poor condition, we chose A. Well, that's because here, when they have a bunch of these people in poor conditions, when I lump them together, they're all pushed together. Okay, it's not accounting for how many people were in that bad condition. All right, that, remember, is known as a working variable. Okay, which leads us into Simpson's paradox. But there's are the examples for chapter 2. If you didn't catch the first video, please go back and check out that.